So this will conclude the lesson on arc length, and we're going to look at arc length of a function in terms of y, where we're actually swapping the roles of x and y. The formula is the same that we saw today in terms of x, but instead we're in terms of y. Everything is in terms of y, and we're going to integrate with respect to y. So your limits of integration are written in with respect to y as well as the integral. So the example that I didn't get to, where we're asked to find the arc length of the curve, and again it's written in terms of y, and the limits of integration are also in terms of y. So this is a little tricky algebraically, and I just wanted to go through this with detail so that all the algebra can be seen here. So first order of business is to take the derivative. Oops. Let me erase that. To take the derivative of that function, and y prime is, I'm going to work with a negative exponent. The derivative is just y cubed minus 1/4 y to the negative 3. So I'm going to rewrite that as y cubed minus 1/4 y cubed. Okay, so substitute into the equation, and this is where it kind of gets a little bit messy. So the arc length is simply the root of 1 plus the derivative squared. And that's going to go from 1 to 2, and you're going to integrate with respect to y. So we're going to do an expansion here, and then combining algebraically, and then look for a square of a binomial. So algebraically, we're going to expand this term. So we're left with 1 plus y to the 6th minus 1/2 plus 1/16 y to the 6th. And how did I get that? All that I did was FOIL that out. Let me grab another ink. So your first is y to the 6th, and your second term, or your outer term, is minus 1/4 y cubed over y cubed, okay, and your inner term is the same, and your last term is 1/16y to the 6th. So y cubed over y cubed is just 1, so negative 1/4 plus a negative 1/4 is negative 1/2. So you've arrived to this term underneath the radical, and then I would combine your constants. So this is the root of 1/2 plus y to the 6th plus 1/16y to the 6th. So now you need to look at that trinomial and try to get it into a square of a binomial so that we can take the root of it. And it does. This is the equivalent of the root of, and you'd have to check it to make sure you're right, y cubed plus 1/4y cubed square. And you can verify that, you know, if you expand that, you get back to here. So that works out nicely because we can, and all of these, as I said today in class, are going to either work out to be this kind of situation or where you can't do any more algebra and you need to do a U sub, or, you know, actually solve the integral in some other way. So here you're left with a pretty simple integral that you can apply the power rule to. So this is just y to the fourth over 4, taking the antiderivative, minus 1/8 y squared. And evaluate it between 1 and 2, and you're left with 4 minus 1/32, minus the quantity of 1/4, minus 1/8, and doing all the mathematical computations, you're left with 123 over 32. And that's it.